My name is Gene Carter. I'm the International Product Manager for NXP Microcontrollers. Today we're going to talk about ecosystems. So we're going to talk about things like our free MWin graphics library, our NXP USB lib, some of our tools, SimSys drivers, and a whole host of things. So hopefully you'll have a better understanding about, once you get our boards, how to get up and get started and get running very quickly. So first I'll give you an overview of the LPC portfolio, all of our microcontrollers in the ARM family. Then I'll hand it over to Henrik, and he will give you an idea about our hardware tools, software tools, the stacks, operating systems, and then we're going to finish it with a small demonstration of these tools in action. All right, so what is LPC? So LPC are the NXP microcontrollers. We've been exclusively ARM since about 2003. We're actually the first ones to do a flash microcontroller in ARM. And since then, we've done hundreds upon hundreds of different ARM microcontrollers. So what makes it easy for you is we try to make a scalable continuum for these parts. So we try to give same pinouts within series and between cores. We try to keep the IP the same, so you can use the same IP from one to the other. You write code for one, you can migrate it to others. We use the same hardware, same tools, same tool set, tool chains, so that what you learn on one is migratable, transferable to other devices. And ARM, one of the strengths of ARM is the ecosystem that we have. So it's a very rapidly growing ecosystem, from anywhere from the free all the way up to the high end with the greatest support that you could possibly find, and everything in between. So whatever suits your needs, whatever you want, whatever kind of support you want, it's out there for ARM. So that's one of the real strengths of ARM. And then one of the things that sets NXP apart is our innovation. We've won a lot of awards. We have a lot of interesting peripherals that you don't find in other people. So it's not just the core, it's how you architect around it, the peripherals you put around it, even the buses and everything that you put on it. So we try to get very innovative on the way we do this to make your job easier and to solve problems that you may have. So this gives you an overview of the LPC product lines. So we have anywhere from the very low end we call the LPC Go. So this is the real entry-level parts, the very lowest cost, lowest power parts that we have. We have the LPC Connect, which basically adds a single significant serial peripheral to it, such as USB or CAN. Then we have LPC Connect Plus, which may have multiple ones of these serial things like Ethernet, USB, CAN, LCD. And then we have LPC Turbo, LPC Connect Turbo, which had even higher performance and higher flash and RAMs. And then finally, we have LPC Command, which is basically our ARM 9-based devices that run Linux. So we tried to give you a pretty broad base portfolio to choose from, depending on what your requirements are. And as you can see, on the y-axis, we have the varying flash sizes, and on the x-axis, you have all the different pin configurations. So what do each of these lines bring you? So LPC Go is really meant for very fast time to market, very low cost, low power consumption, and really is your 8 and 16-bit replacements. These things start as low as 40 cent and 10K quantities for a 32-bit microcontroller. So it's getting harder and harder to justify staying with an 8-bit device for those kind of price points. And not just the price, you get the same kind of power consumption that the 8-bits have, with performance that blows them away. And then LPC Connect, so point-to-point connectivity with performance and integration. So if you attended our USB session, or you will attend it, you'll see how easy it is to plug and play for USB, for example. That's part of our Connect line. We put things like USB drivers in ROM on the chip, so all you have to do is make an API call. You can program the part just by drag and drop. These are really meant to be very simple connectivity. LPC Connect Plus then adds additional bandwidth if you want to run multiple peripherals at once. You can run Ethernet and USB simultaneously, or make a CAN bridge to Ethernet, or any kind of peripheral bridges you want. These are the ideal parts for that. And then LPC Connect Turbo gives you that additional performance that you may need to then run high-speed USB or some other type of peripherals. Also, we add the highest, most advanced peripherals that we have, like the serial GPIO or the SPIFFE and also the dual cores are in this family. So we have a dual core M4, M0 part. Those are all in the LPC Connect Turbo line. And then finally LPC Command, which as I mentioned is ARM9 based, and if you want to run Linux, you need an MMU, and so that's the right line for you if you want to run a full Linux operating system. And then the other thing we do to try to make it easy for you is give you these bridges. So we have form, fit, function replacements between different cores. So in the upper left-hand corner there, you see the 11U and the LPC 13.4, pin-compatible M0, M3 solutions. So you need a little more performance, you can move to the 72 megahertz M3. You want the lowest power consumption, you move to the M0. And we have similar there as you go around between ARM7s and Cortex M3s, M3s and M4s, even ARM7 M3, M4s in the same pinout. So we have a lot of flexibility. You choose the core that's right for you, and then you can even migrate without changing your board from core to core. Okay, so that's a quick overview of our portfolio. I'm now going to turn it over to Henrik, and he's going to give you a lot more detail on the ecosystem and how to get started.
So my name is Henrik Flodell. I'm the tools manager at NXP, and I'm going to start this presentation by talking a little bit about a website that we have that's called lpcware.com. So lpcware.com is basically our engineer-to-engineer website where we post all the technical information that we have available about all our parts, all our boards, and basically all the tools that we have in our ecosystem. You'll find things on LPCware such as application notes. You'll find schematics for boards and reference designs. We have forums. I think we have, at last count, it was the number of users were in the thousands anyway, active users on the forums that are sort of discussing the designs that they're working on. We have several blogs that are up on the site where most of our application engineering team and also some of our FAEs go in and sort of blog about things that they've seen people do using the parts, and also users that are registered can also talk about designs that they're working on. And we're really putting a lot of effort into making sure that the information on this website is always updated and that you will be able to find the most sort of accurate technical information about everything that has anything to do with NXP parts on there. So, and everything that I'm going to show you today with regards to software and various stacks and such is all available on LPCware. So, the first thing I want to start by talking a little bit about is IDEs, compilers, development tools, basically. I mean, it's you know, you have to start somewhere, and the IDE, especially the debugger, is where you will spend most of your time when you're developing something for one of our parts. So we have a pretty broad support across the industry for our parts in various IDEs. We have our own IDE that's called LPCXpresso. Well, not, you know, it's not really our own. We OEM it from Code Red Technologies. It's basically an NXP-only version of their Red suite. But the nice thing about it is that it's free of charge. You don't have to pay anything for it. It supports all of our parts, and the only limitation is that you can only download and debug applications that are less than 128K. But it's still a very generous limit compared to some of the other tools that are out there. So that's available. You can go to our website, you can download that, you can start working with it today. Kyle, IAR, those are two pretty big names in the industry. I mean, their tools are pretty common. They all support all of the parts that we have. Rowley, Crossworks, and Atomic are also two kind of, I don't want to say, well, they're basically lower cost IDEs, and they also have support for our parts. And the GNU compiler that Code Sorcery maintains also has a lot of NXP support. So there's a lot for you to choose from when it comes to development tools for the NXP parts. Hardware debugging. Like I said, this is probably, unfortunately I should say, the area where a developer spends most of his time in the debugger trying to figure out why it doesn't do what you want it to do. We work with as many people as we can in the industry to make sure that they have good support in their debuggers for our parts. And since we're using ARM exclusively, we can also benefit from the fact that ARM has a very broad support in the industry. And there are a lot of development tools out there that support various debug methodologies and ARM cores. So these are some of the debug probes that can be used together with NXP parts. And there's a lot of like more advanced debuggers, like the Lauterbach stuff that I'm not even mentioning on this slide, but there's support in that one as well. We use them all the time when we're developing the parts in-house. When it comes to development boards, rapid prototyping, whatever you want to call it, we have, I think at last count, there was about 86 active development boards in our portfolio. And these development boards, they span from very advanced sort of reference designs for very specific things to tiny low-cost boards that are just meant, you know, you can pick them up, you know, buy 2, buy 3 for you know, 20, 30, 40 bucks and play around with them. We work with a lot of board vendors, and we try to make sure that we have, for each part that we come out with, we have at least one board design. Preferably, we want to have a couple of them. We want to have some boards that are more advanced, some boards that are, like I said, just easy, just, you know, a couple of pins, the part. And we try also to always make sure that there are boards that have the debug connection on board, so you don't have to invest a lot of money in getting a standalone debugger before you can start evaluating the part. So I'm going to go into more detail about Xpresso and Mbed in a little bit, but I want to mention the NGX Explorer that is on this slide. This is a board that we've recently come out with for our LPC 4300 and LPC 1800 families, together with a company called NGX. And if you attend the, I think it's the advanced peripherals session tomorrow, and check out sort of some of the peripherals that are actually on the parts that are on those boards, we'll give you one of them for free. So that's something I just want to plug. So LPCXpresso. This is our own low-cost development platform that we developed together with embedded artists and Code Red, I think it was. So it was a couple of years ago when we sort of announced it. So LPCXpresso, the IDE, is the main component of it. I've already mentioned that. That's the big block on top there in the diagram. The Eclipse-based toolchain, 128K limit for downloading code to the target. And then we have these low-cost development boards that we call Xpresso boards to sort of go with the entire platform. And the neat thing about this board is that it comes in 2 parts. I mean, they're together, but they perform two separate functions. One side of the board is the debug link, and the other side of the board has the target part on it. So the debug link and the target board can be separated, either if you just sort of cut the board in half, like we've done in this picture, or if you cut the traces on the boards. And then you have a standalone debugger that you can use then to debug your final design. So basically, you can get started using the Xpresso board for just rapid prototyping. And once you've figured out that, okay, this is basically what my software is going to be like, I'm going to start designing some hardware now, you can keep using the link to debug your own hardware, still using the LPCXpresso IDE. So this is sort of an illustration of just that. You have the evaluation stage where you have the development board using the link, the IDE. Then we have an explore stage, and this is sort of if you want to do some more advanced evaluation of the part, we have base boards that you can connect it to. These are like ready-made boards that has peripherals, all sorts of peripherals on them. They have displays, they have potentiometers, they have a larger prototyping area, and you can just plug the link board into one of these base boards and do some more advanced developing before you sort of go into the final stage where you stop using the target part of the Xpresso board and start using your own hardware. Mbed is another thing I want to mention. This is an initiative that we're working on together with ARM. So basically what Mbed is that it's a tiny board that has, a unique form factor, and it also has a set of development tools and library that are cloud-based. So you don't actually need to install anything to get started with an Mbed part. What you need to do is you need to get a board, and then you go to Mbed's webpage, create an account, and then you have the compiler and the entire sort of Mbed community online. I think the last number that I heard was that about 50,000 Mbed boards in total have been shipped. So it's a very active community, and it's just full of people that are coming up with some amazing designs. And most of it is just out there for you to sort of play around with. You can grab some libraries, import that into your project and start developing. So some of these boards here that you see on this slide is also like expansion boards for the actual Mbed board. The Mbed board is the small one to the right. And then you take that board, you plug it into one of these expansion boards, and then you have ports that you can connect. You have Ethernet PHYs, you have USB PHYs, you have displays, whatnot. These are available from several locations. Several resellers have them at very sort of competitive pricing. FlashMagic is another tool that NXP is working on together with Embedded Systems Academy. And this is basically a programming tool. You use it to program parts using either serial or an Ethernet protocol that we've come up with. So the parts the chips has a little bit of ROM that can communicate with the tool that allows you to just do in-field programming, or if you just want to, replace whatever firmware you have in something in a quick and easy way without having to break out your entire debugger and your entire tool chain. And it can do most of the sort of configuring of the chip that you would expect a tool like this to do. You can program security bits, you can reprogram boot vectors and things like that, read device signatures and make sure you're talking to the right device. And this is also free, it's available online. We have a PinMux tool that we publish. I think we publish a new version of the PinMux tool for every new part that we come out with. And what you use this for is basically to help you configure your pins. The nice thing about it is that it's graphical. So you have you can just go in and click on the pins that you want to be changed from the default, set it up to what you want it to be, and it can tell you if you've created a conflict somewhere in your setup. And then this tool generates source code that you can just take and you can put that into your project, regardless which IDE you use. It creates ANSI-compatible C code. All right, so I want to talk a little bit, just give you an overview of some of the software packages that we have available at LPCware for NXP parts. The main one, or the main one, one of the main ones is the USB library, NXP USB Lib. Which is a free, open-source, full-featured USB library designed to run on all capable LPC microcontrollers. It can run in either host or device mode. And we use it, if you go into the exhibit area and take a look at some of the demos that we have there, you'll find that a lot of them are based on that USB library. So it's quite capable, it's free of charge, and it's open source. So you can get the source for any of the parts that it supports from LPCware. We're also using the lightweight IP networking stack, LWIP. This is a free IP stack that is developed by the Swedish Institute of Computer Science. And it's particularly targeted for small microcontrollers, and it has a very small footprint. It's very configurable. You can get it down to as small as, I think they say that it's about between 4 and 9K, depending on which options that you include. So you can use that either standalone, or you can use it with an RTOS. And we have support for free RTOS in the software packages that we have up on the site. We have a graphics library. The graphic library that we have on LPCware is Sega's MWin library, which we provide free of charge for any LPC device. So I assume that some of you know about MWin already and what you can do with it. Again, most of the demos that we have at the exhibit is based on MWin. There's a couple of them that is based on another library, but most of them are MWin. And this is a library that usually you have to license from Sega to be able to use in an application. But if you use an LPC part, you get it for free. Real-time operating systems, real-time kernels. Free RTOS is the one that we have most support for up on LPCware right now. We have some software up there also that is ported and that is running on Micrium version 2. We have done we're doing some work on Micro COS 3 support. But FreeRTOS is sort of right now the main one that we support. There's also Linux support in the form of micro C Linux, which is basically Linux for microcontrollers that do not have an MMU. We have ports of that for the LPC 1800 and LPC 4300 series parts up on LPCware, if you want to experiment with that. And then to tie it all together, we have created something that we call the LPCOpen Platform. And this is basically everything that I've just been talking about. You have MWin, you have LWIP, you have the NXP USB library, you have FreeRTOS, and you also have driver layers. So you have driver libraries for all the peripherals on the chip. You have board support packages for the development board that we come out with, so that you can develop against a common API regardless of which part or which board that you're working on. And all of this is just tied together into one big package that you can download for any of the major IDEs. So you have, for instance, if you want to use LPCXpresso, you download the Expresso version of the Open Platform, and you get all of this code together with sample applications, so you can just either start modifying those to suit your needs, or if you just want to experiment with them and see what they can do, you can just use it as is. So MWin, if I want to go into a little more detail about that, it is a graphics library, and one of the nice things about it, it supports all different types of LCDs. It doesn't matter if you use a monochrome, if you use grayscale, or if you use a color LCD. And you can use it with either our parts that have LCD controllers on board, or if you use a part that do not have an LCD controller on board, you can use it with just any SPI-based LCD panel. We provide application notes on LPCware that show you how to port MWin across to, so I should say this, we try to support MWin on any of the parts that we come out with, but if you're using a part that there's not an MWin port out for yet, we have application notes that show just how easy it is to port it across to something new. It takes about, I would say, maybe 2 to 3 hours to get it all done and tested. There's projects available up on LPCware that shows how to do this for both Kali, IR, and Expresso. And as you can see on the resource requirements, you can get the footprint down to very little if you don't use some of the more advanced features of the library. And it's free if you use an NXP device. This is some examples of some applications that are using MWin. Washing machines, all sorts of home automation panels, white goods displays. And like I said, we have a number of demos in the, out in the showroom where you can see MWin in action. There's another graphics library that we have up on LPCware that we call Swim. And this is something that we developed ourselves. It is a very, very basic graphics library if you want to just, put something together that doesn't have to be super advanced. Supports basic fonts, ASCII characters. You can do boxes, set colors, do display bitmaps. And the nice thing about it is that it requires very little overhead. We have a demo in the showroom it's basically a Pong game. So you control the paddle and you try to deflect all the balls that come at you. And we've done that demo using the Swim library if you want to check it out. There is, again, application notes, support for the major IDEs, etc. Everything up on LPCware. FreeRTOS, like I mentioned, the RTOS of the LPC Open Platform package, royalty-free, open source. One thing about FreeRTOS is also that you can get support for it. You can get commercial support for it. So the FreeRTOS is like the open source version. There's open RTOS and there's safe RTOS that is based on the same kernel. And that's basically a way for somebody who's interested in getting commercial support for this package to buy that from the creator. So it's nice in a way that you can get it for free and you can start using it. And then if you realize that this is something I really want to do, but I fear that, the way that I'm using it, I need to protect myself by getting some support later on, there is the option of getting that. And there's also some free extensions. These are extensions that you usually have to pay for, but you get for free when you're using them with NXP MCUs, such as the peripheral interface abstraction and the command line interface to control runtime tasks. All of that, lpcware.com, once again, that's where you get everything. It's very easy to implement. There's 3 files, you add those to your project, and that sets up the RTOS, and then you have a scheduler running that you can start spinning off threads on. Many example projects is available for various IDEs, and there is a book about FreeRTOS that is basically based on the LPC 1768 part that we have that you might want to check out as well. So NXP USB lib, I talked about that a little bit before. This is a graphic that shows some of the device classes that is included in it. Audio is the latest class that we've implemented, and you can also do composite devices with it. So if you want to have, one USB device be many things, it is possible to configure the library to handle that. Support for NXP USB lib is being added to any part that we have that supports USB, including the parts that have USB drivers in ROM, such as the 1800 and the 4300 for the high-speed interface, and some of the Cortex M0s and their full-speed interfaces. So again, lpcware.com is where you get this, and there's a host of sample code available in the NXP USB lib package that shows you how to implement the various sort of USB classes that the library supports. LWIP, like I said, very low footprint, and it's very configurable. It supports most of the common protocols that you use in a networking application, and you can configure it to just not include support for the protocols that you don't expect your device to handle in order to decrease the footprint of the stack. We have 2 versions of it available for our parts. We have the standalone version, which is slightly smaller, but does not support being run from an RTOS thread, or we have a threaded implementation that is compatible with FreeRTOS. So, and you can easily take that and modify it to use it with other RTOS if you want to use something like microCOS or Nucleus or whatever. So that's that. This is another thing that we have available. This is not part of the open platform because it's a bit special. This is our motor control library. We have some development boards. We have an Expresso board in particular that is basically a reference design for motor control. And all of the code that we've written for that is based on this motor control library. It's designed in such a way that depending on which motor you want and depending on the application that you want to create, this library helps you just by providing underlying functions for most of the kind of control functions that you might want to create in your application. So it is available, but it's not part of the open platform. And I want to show you a quick demo of the open platform on a board that I have up here. The board that I'm using is a Kyle board. We made this together with Kyle a while ago to show off our Cortex M4 M0 dual core processor. The board has a bunch of memory on board. For this particular application, we're running it out of the Quad SPI flash. So we have a peripheral in this part called Spiffy that allows you to execute code from SPI flash, which is really nice. Board has a color LCD display, which we will be using. And I wanted to show you this example running actually using the USB features of the part, but I wasn't able to find any USB microphone or speakers to use for it, so it has to be analog. But it would have supported USB if I had access to the hardware. Basically what it is, it's a voice recorder demo. So you can record and play back audio samples, and because it has a Cortex M4 that has DSP features, we added some basic like filtering and reverb functionality to it. And we did the GUI using MWin, and we're using our low-level sort of peripheral driver library in the Open Platform to implement reading and writing the audio files to a SD card using a FAT file system. The part supports dual host mode, so if I connected a USB speaker and a USB microphone to it. So the analog is being handled by a codec that is on board and then just sampled to the microcontroller. But this is a demo that we made in a couple of days using the Open Platform. It's not quite ready yet. There's a couple of more features that they're going to implement, and once that's done, it's going to end up on LPCware as well. So you can download that and from there and check it out. Some of the reasons this is one of those slides that we like to put at the end of presentations where we sort of go through and mention some of the things that we talked about. And as you can see, we talked about the ecosystem now. We talked a little bit about display, a little about USB, and a little bit about connectivity. But there's a lot of other things, of other reasons for you to choose an LPC or an NXP LPC microcontroller. And I would like to once again remind you that there are sponsored sessions tomorrow that go through some of the other things that you see on this slide, where you can get sort of even more information on what we have that can make your life as a developer easier. Also, this is available in our booth on the floor. We have the tools Linecard that has basically all of our parts. Actually, no, we don't have this printed with us. The tools line card is available on our website. What we have the parts line card available on the show floor, so you can look that up for the specific part you want. The tools line card, however, I want to plug this because it's very comprehensive. It's basically a list of every single vendor that provides something to our ecosystem, what they provide, for which parts, etc. So it's a very good reference for you to look up, if you have a specific piece of software that you would like to use in your next design and you're wondering, well, can I use that on an LPC microcontroller? Well, this is your reference. It will be able to, it can tell you if it's compatible or not. And also our offline chip selector guide, which can be very handy if you don't want to parse through the entire sort of chip selector tool card that we have. You just download this, install it, and then you basically select, these are the peripherals that I need in my part. Boom, it will tell you exactly which parts that are applicable to you. And last but not least, I want to plug our another website we have called LPC Zone. This is not really a website, this is our YouTube channel. So we post a lot of videos on like simple board demos, more advanced sort of like learning capsules. We're filming all these sessions that we're doing here right now. They're going to end up here eventually. I advise you to go check it out. There is a lot of information there about our parts, and we are constantly adding to it. So that's that. Thank you very much.